Here's something that almost never gets said clearly in climate coverage. Climate change does not look the same everywhere. It does not feel the same everywhere. And it does not threaten the same things everywhere. Someone watching floodwaters rise in Louisiana is living a completely different climate reality than a rancher watching their well go dry in New Mexico. A fisherman in Alaska watching the sea ice disappear is experiencing a different version of this than a homeowner in Miami watching salt water come up through their storm drain on a sunny afternoon. But all of these people, all of these very different realities, are chapters in the same story. Today on this channel, we are going to walk through the United States region by region. No politics, no arguing about whether this is real. The data is the data, and I am going to give it to you straight. What is actually changing, how fast, and what it means practically for the people living in each part of this country. Let's start at the global baseline and work our way down to your neighborhood. Before we go region by region, let me give you the numbers that set the stage for everything else. Global average surface temperature in 2026 is running approximately 1.3 degrees Celsius above the pre-industrial average, the baseline calculated from the period before significant fossil fuel combustion began, roughly the mid-1800s. Atmospheric carbon dioxide is at approximately 427 parts per million. To put that in context, CO2 levels during the entire period of human civilization, the last 10,000 years, never exceeded 300 parts per million. We are now 40% above the ceiling of the entire human civilizational era. Why do these numbers matter? Because they represent the changed baseline that every weather system now operates within. When a heat wave develops in 2026, it starts from a warmer floor. When a hurricane forms in the Atlantic, it is over warmer water. When a drought settles in, it is evaporating moisture out of soil that is already drier and warmer than it was 50 years ago. The analogy I find most useful is this. Imagine a basketball court where someone has quietly raised the floor by 6 inches. Every player is still playing basketball. The rules have not changed, but every jump is higher, every landing is harder, and anyone trying to play defense at the rim is at a disadvantage they cannot explain until they look down and realize the floor moved. That is where we are in 2026. The floor has moved. Now let's go region by region. The Northeast, New England, New York, Pennsylvania, New Jersey, and the Mid-Atlantic states is warming at roughly twice the global average rate according to NOAA's National Centers for Environmental Information. That is not a misprint. The Northeast is one of the fastest warming regions of the continental United States. Why? Partly because the North Atlantic Ocean, which moderates the Northeast's climate, is itself warming rapidly. A particular area of the North Atlantic, called the Atlantic Meridional Overturning Circulation, the ocean conveyor belt, is slowing down, and the evidence is pointing toward this slowdown as a driver of amplified warming and more volatile storm patterns along the northeast coast. Sea level along the northeast coastline has risen approximately 14 inches since 1950, faster than the global average, again because of the slowing ocean circulation. Boston, New York City, Philadelphia, and Baltimore are all now experiencing what scientists call sunny day flooding. Streets that flood not because of rain, but simply because high tide is high enough to push water through storm drains and up into low-lying neighborhoods. This is happening dozens of times per year in some coastal communities. Winters in the Northeast are shrinking. The number of days below freezing has declined significantly over the past 50 years. Ski resorts across Vermont, New Hampshire, and upstate New York are surviving on snowmaking technology. That was not necessary in this volume 30 years ago. Meanwhile, nor'easters, the powerful winter storms that have always been part of Northeast life, are becoming more intense when they do occur, because a warmer atmosphere loads them with more moisture. The honest comparison, a nor'easter in 2026 carries more water vapor than the same storm track in 1985. When it snows, it can snow heavier. When it rains, the totals are bigger. The storm itself follows the same physics, but the fuel it is running on is richer. Move south to the Carolinas, Georgia, Florida, and the Gulf states, and the climate signal shifts. The Southeast is not warming quite as fast as the Northeast, but the impacts it is experiencing are, in many ways, more immediately threatening to daily life. The number of days per year where the heat index, the feels-like temperature combining heat and humidity, exceeds 100 degrees Fahrenheit has roughly tripled across parts of the Deep South compared to the 1970s. Miami now regularly records heat index values above 105 degrees in summer. Outdoor workers, elderly residents without air conditioning, and low-income communities in urban heat islands are bearing the greatest health burden from this change. Hurricanes in the Atlantic are not necessarily becoming more frequent. The data on total hurricane count is mixed, but they are becoming more intense at landfall, more rapidly intensifying, and slower moving. A slower moving hurricane drops more rain over the same area. A rapidly intensifying hurricane gives coastal communities less time to evacuate. Hurricane Ian in 2022 intensified by 65 miles per hour in a single day before making landfall in Florida, an extreme example of the rapid intensification that warmer Gulf waters are enabling more frequently. Florida's challenge is particularly acute because of its geography. It is flat, low-lying, and surrounded by warming ocean on 3 sides. Miami Beach now floods during high tides regularly, not from storms, but from the simple, arithmetically certain fact that the ocean is higher than it was. Miami-Dade County is spending hundreds of millions of dollars raising roads and installing pump systems. It is a direct, measurable, expensive response to measurable sea level rise. The Midwest is experiencing what climate scientists call a feast or famine precipitation pattern. Total annual rainfall has not changed dramatically in many Midwest locations, but how that rainfall is delivered has changed fundamentally. Rather than steady, moderate rainfall distributed through the growing season, the Midwest increasingly experiences intense rainfall events. Days where 3 to 5 inches fall in a few hours, interspersed with extended dry periods. The soil cannot absorb intense rainfall efficiently, so more of it runs off into rivers, causing floods. Then the dry periods that follow bake the topsoil, reducing its water-holding capacity and stressing crops. The spring of 2019 gave the country a preview of this pattern's destructive potential. The Missouri and Mississippi rivers flooded for months, not because of a single dramatic storm, but because of a winter and spring pattern of intense precipitation events that kept rivers high continuously. Billions of dollars of crop damage and infrastructure destruction resulted. The Great Lakes are also changing. Lake surface water temperatures have risen significantly over the past 50 years, producing less lake effect snow in some areas. A shorter cold season means less cold air to drive lake effect, while producing more intense individual lake effect events when they do occur. Lake levels have shown extreme variability. Record lows in the mid-2010s were followed by record highs just years later. This volatility itself is a climate signal. Derecho events, the violent, fast-moving straight-line windstorm complexes that have always been part of Midwest summer weather, appear to be increasing in intensity. The August 2020 Iowa derecho caused over $11 billion in crop and infrastructure damage in a single event. The atmospheric conditions that produce derechos, extreme heat and instability, are becoming more frequent. The South and Gulf Coast are living at the intersection of 2 amplifying climate signals, extreme heat and extreme water. Houston has experienced what NOAA has described as a 500-year flood 3 times in the space of a few years, in 2015, 2016, and 2017. The statistical impossibility of that sequence is explained by the changing atmosphere, warmer Gulf of Mexico, waters loading tropical and non-tropical storm systems with more moisture, and a climate pattern that favors stalling weather systems over the same geography. A direct comparison makes this vivid. Hurricane Harvey in 2017 dropped more than 60 inches of rain on parts of Harris County, Texas. Climate attribution studies, research that quantifies how much more likely or intense an event was because of climate change, found that Harvey's extreme rainfall was made approximately 15% more intense and 3 times more likely by climate change. That is not a speculative number. It comes from peer-reviewed research in the journal Nature. The heat index in parts of the Gulf South now regularly reaches levels that pose genuine physiological danger to unprotected people within 30 minutes of outdoor exposure. Wet bulb temperatures, the threshold at which the human body can no longer cool itself through sweating, are being approached or briefly exceeded in parts of the Gulf Coast for the first time in recorded history. The Great Plains story is, in many ways, about what is happening underground as much as what is happening in the sky. The Ogallala Aquifer, the massive underground water reservoir that stretches from South Dakota to Texas and supplies irrigation water for a significant fraction of U.S. food production, is being depleted faster than it is recharged. In some areas of Kansas and Texas, water levels have dropped 150 to 300 feet over the past 60 years. The recharge rate, how fast rainwater percolates down to refill the aquifer, is measured in fractions of an inch per year. At current depletion rates, large portions of the southern Ogallala could effectively run dry within decades. At the surface, drought cycles are intensifying. The term megadrought, defined as a drought lasting more than 20 years, has re-entered scientific literature to describe conditions in parts of the Western Plains and the Southwest. The drought of the Dust Bowl era in the 1930s is the historical reference point most Americans know. Current paleoclimate research suggests that the ongoing drought in the western United States is approaching, or may already exceed, Dust Bowl conditions in some metrics of severity. Wildfire on the plains is also changing. The Texas Panhandle wildfires of February 2024, burning in winter, a season that historically had low wildfire risk on the plains, demonstrated that warmer, drier, and windier conditions are extending the wildfire season into months that were once considered off-limits. The American West is experiencing the most visible and Dramatic collection of climate impacts in the continental United States. The Southwest and desert, Phoenix, Arizona recorded 31 consecutive days above 110 degrees Fahrenheit in the summer of 2023. Lake Mead, the nation's largest reservoir by volume and the source of water for tens of millions of people across Nevada, Arizona, California, and Mexico, dropped to its lowest level since it was filled in the 1930s. The Colorado River, the lifeblood of the entire Southwest, is being consumed by 7 states, Mexico, and multiple native nations at a rate that exceeds what the river actually carries in a typical year. Climate change is reducing the river's flow even as demand grows. The Mountain West and Rockies. The snowpack that feeds western rivers, functioning as a natural reservoir that melts slowly through spring and early summer, is declining in volume and melting earlier. Earlier snowmelt means peak river flows arrive before summer irrigation demand peaks, and then rivers run low precisely when crops, cities, and ecosystems need the water most. Mega wildfires, fires exceeding 100,000 acres, have become a regular summer feature of the West, not an exceptional event. The Pacific Northwest, the 2021 heat dome that killed over 800 people in the Pacific Northwest and Canada, in a region that had never recorded temperatures anywhere near what was observed, put on stark display what climate change looks like when it arrives in a community. That was not designed for it. Seattle's building stock has historically required almost no cooling infrastructure. The 2021 event changed that understanding permanently. Wildfire smoke now blankets the Pacific Northwest for 4 or more months of the year, creating a public health crisis that did not exist in this form 20 years ago. Alaska. Alaska is warming 3 to 4 times faster than the global average. Permafrost, ground that has been frozen for thousands of years, is thawing across wide areas, releasing stored carbon and destabilizing the infrastructure built on top of it. Roads buckle, buildings tilt. Coastal villages are being eroded by waves that used to be blocked by sea ice, ice that no longer forms reliably. Several Alaska Native villages have voted to relocate entirely, making them among the first climate refugees within the United States' own borders. Here is the most important thing I can leave you with. Climate change does not erase weather. Cold days still happen. Wet springs still happen. Not every extreme event is directly caused by climate change in a simple, one-to-one way. But every weather event now occurs in a changed atmosphere. Every heat wave starts from a higher floor. Every hurricane forms over warmer water. Every drought dries out soil that is already predisposed to dryness. The direction of the change across every region of the United States is unambiguous in the data, and that data comes from NOAA, NASA, USGS, and the IPCC, not from any single political or advocacy perspective. Understanding what your specific region is experiencing is not about alarm. It is about preparation, adaptation, and making informed decisions about where to live, how to build, how to farm, how to insure, and how to plan for the future that the data is pointing toward. The sources I rely on for this reporting, NOAA's NCEI, the EPA's climate change indicators, the USGS water resources data, and your state climate office, are all publicly accessible and free. I will link the most important ones in the description below. This is the first episode of what will be an ongoing regional climate series on this channel. If you found this useful, please subscribe and share it with someone in one of the regions we covered today. The more people understand what is specifically changing in their part of the country, the better equipped communities are to respond. I will see you in the next one.